Okay, this is 2008 BC multiple choice. Okay, we're continuing on number 17. So see what you think it looks like. Maybe look at the answer choices. Looks to me like a partial fractions problem. So this is 7x over 2x minus 3, and then x plus 2 equals, and then you put 2x minus 3 in one fraction and x plus 2 in the other fraction. And then remember, you have to check whether the denominator is linear or quadratic. So on the BC test, they're all going to be linear. There's no repeated linears, but in college you might have repeated linears and you might have quadratics, but that's in your normal notes. Okay, so on top of a linear we put a constant. Then on top of a linear we put a constant. If it was a quadratic, then you have to put a linear on the top. So say you had a quadratic like this that you couldn't factor, then you put bx plus c at the top. Like mx plus b, but with different letters. Okay, but you don't have any of those on the exam. Okay, so let's see. So the best way to show your work on this is to find a common denominator. So this one needs a 2x minus 3. This one needs a 2x minus 3. This one needs an x plus 2. And this one needs an x plus 2. And then all the denominators match. Okay, so then you have the numerator of the left side equals the numerators of the right side. But I usually don't distribute them. Okay, then what I do is I pick numbers. There's two ways. I called it method 1 and method 2 in class. Okay, so this one is method 1. Method 1 is you substitute. So you substitute the negative 2 in because this has to work no matter what. So it has to work for all values of x. So I'm choosing a value of x that makes this one equal to 0. That's how I picked it. Okay, so this is negative 14 equals 0 plus b times negative 7. So b is 2. Going to need that. And then I label the next one. So x equals 3/2. I picked that because that's what makes 2x minus 3 equal to 0. That's how I picked this. And then I substitute. And I'm substituting it into this step. So that's 7 times 3/2 equals a times 3/2 plus 2 plus b times 0. And that would be 21/2. And that's a, let's see, common denominator. Let me change colors. That'd be times 2 times 2. So that's 7. Okay, so that would be 3 plus 4, which is 7/2. And then you can multiply by the reciprocal. So 2/7, 2/7. And then a turns out to be 3. And then what I had told you is that I usually take the antiderivative, especially, I'll show you what I mean, but I'm going to put this down here. I usually go from the red up here, and I take the antiderivative before I find the letters. Okay, I'm just used to for years not having done that. But it really helps. If you do this, you'll get a lot of partial credit, especially on the free response. Okay, because the integral portion is more important than the a and the b specifically. Okay, so for this one, this would be u equals 2x minus 3, so du equals 2 dx. So you're going to need a 1/2 in the front. You can also do a full u substitution. So this is a over u times 1/2 du, okay, or du over 2. Okay, and then this one is b over a different u. It's not really u anymore. Maybe we'll call it m substitution. M is x plus 2. And then dm equals 1 dx. Okay, so this is u. Well, m. This is m, not u. Okay, so this is m. Dm, I guess. Okay, so this one on the left, and you wouldn't have to show that step. You probably could just do 1/2 ln absolute value of 2x minus 3. Often I forget the a, so I forgot it again. So I'm going to put an a at the top. So this a this A, we do need to have there. And then the other one is plus B ln absolute value of m. But what's m? So probably you would skip that step and you would just do x plus 2 plus c. And now I did already find a. So a is 3/2 ln. But you don't want getting stuck on finding a and b, meaning that you can't take those antiderivatives. So that's why I usually take the antiderivatives first. Let's see if they have one that's exactly my answer. They do, so probably the answer is A, unless I made some error, which is possible since I don't have you guys checking with me. I really count on that now. I count on that. I count on you guys saying, hey, Ms. Nichols, your 3 turned into a 5, you know, or random stuff. Okay. But anyway, so I think that one's good. Okay, so this one's 19. Okay, so let's see, 20. What is the sum of the series? Okay, so sum of the series, I call it looks like a known series. So this looks like a known Maclaurin. Or there's no sum. Or maybe it's geometric and we have a geometric sum. So no sum would be because it diverges. And telescoping. Okay, so anytime I see sum, when it applies to a series and they actually want the sum, these are the things I think about. I don't know. I'm feeling geometric. No. My geometric, I was going to say R is ln2. R is ln, but that's not true. That's not true because there's that 2 factorial at the bottom. Okay, so let's back that up and say R is not going to help. Let's go with looks like a known series. Okay, now the Maclaurin series you will need to know for college. Okay, so these are the Maclaurin series. They have removed them from the 2020 AP test. I'm sure they will be back on future AP tests. Okay. Now that doesn't mean you can't use your information. So if for some reason you feel that the things that you learned helps you, absolutely it's allowed. Okay, I kind of like this one. Actually, I feel like this is the one. I see the 1. I feel like if I made x ln2, yeah, I feel like the ln2 is being substituted in. Okay, so this is it. Now, is it missing anything? I don't believe so. So this is going to be E. I'm going to fill in the ln2 for all the x's. We'll only go up to 3. Plus dot, dot, dot. Let me add the nth term. This is x to the n over n factorial. So this would be something plus dot to the n over n factorial plus dot, dot, dot. Okay, Taylor series are on the 2020 test. And then if I substitute ln2 in for every x, yeah, this one's okay. This one's okay. This one's okay. This one's okay. Cool. So the answer is the left side simplified. Okay, so the answer is that cancels and you just get 2. And that's equal to all this. Very interesting. Okay, so 2. So the answer is C. Okay. Let me type telescoping better, or write telescoping. Telescoping. I was looking at my videos, and on 2 of my math analysis videos, people put thumbs down. I'm so sad. I wonder if that's a thumbs down, I don't want to watch your videos, or I wonder if that's a thumbs down because they were confused by my videos. If you are confused by any of my videos, just send me an email. send me an email and I'll clear it up. So that's very sad. Okay, so let's see. Number 21, a particle moves along a straight line. The graph of a particle's position, x of t, at time t is shown. This is another topic we want to make sure we practice some of these as we're practicing our free response topics. A particle moves along a straight line. The graph of a particle's position at time t is shown, 4, 0 to 6. Okay, got that? The graph has horizontal tangents at these numbers. Okay, horizontal tangents. Tangent is about slope. Horizontal, so think of a horizontal line. What's the slope of a horizontal line? So if you think of a little skier standing on the line, no poles, how fast is he going? Is that 0 or undefined? It's 0. Undefined is when it's vertical. So horizontal tangents means m is 0. Now the graph has horizontal tangents at t equals, okay, so here they are saying that slope is 0, and at t equals 5, they're saying the slope is 0. Okay. Okay, I see that. And a point of inflection at t equals 2. So t equals 2, it's like concave up, and then it's concave down. Okay. So point of inflection would mean the second derivative. This is calling it position. So the second derivative at that value, which in this case is 2, is 0 or undefined. But I'm looking at the picture and it's not harsh or jerky or anything, so I think it would be 0. For what values of t is the velocity of the particle increasing? Okay, velocity is supposed to be increasing. They're not saying position is increasing. They're saying velocity is increasing. So I need a velocity prime number line from 0 to 6. Okay, because they want the velocity prime to be greater than 0. They don't want the velocity to be greater than 0. Okay, so velocity prime. Now this graph is a graph of the position. So this is x of t. So if I want the velocity prime means a is greater than 0. A is greater than 0. Now how is a related to v? Right? So a is the second derivative. I want the a to be positive. Also, what's v compared to x? So if x prime of t is velocity, then what's velocity prime? That would be x double prime of t. So this is x double prime, which I wrote over here, right? Okay, so let's make an x double prime number line. So how do I make an x double prime number line? Okay, so let me erase my number line here. And the a, I think, is not as helpful. So we're going to call this v prime. Okay, and then we're going to call it x double prime, which equals a. Okay, so v prime is not on the picture. So if I'm going to look on the picture, I'm going to change that to red. So I'm going to look on the picture, and I'm going to look at the x double prime. So x double prime is the second derivative. So the graph starts off by looking like it has a concavity of up. Okay, so it has a concavity of up at the beginning, and then it says at 2, there's a point of inflection. So concavity up and then concavity down past 2, from 2 to 6. I can't really tell right at 0, because right at 0 it looks like there potentially is another point of inflection. Okay. Hold on, concave down, but I put plus. Okay, so that's wrong. So concave down would be minus. So this is concave down, this is concave up. So what values is the velocity of the particle increasing? So this area, v prime, is greater than 0 from 0 to 2. So I would say 0 to 2. Okay, 0 to 2. T's between 0 and 2. So that's x double prime between 0 and 2. So A. Well, that's an interesting question. If the question was asking about velocity, just is it moving right and left, that would be a v number line and not a v prime number line. Okay, so that would be A. Interesting. Okay, so let's see. We go to the next page. Okay, gives us lots of information. Table gives lots of information. Okay. Okay. So one thing that's hard for students, and that's why I definitely need you to try them first, throw your math at it before you hear my answer, is what method should I use? So when I look at this problem, the first thing I'm thinking of is U sub, okay, but I threw that choice out real quickly. So I was thinking U sub, but then these letters aren't the same. So then it makes me think of parts. Makes me think of integration by parts. So I'm thinking that this could be U, and maybe this could be V, and then this would be DUV, and this would be DU. Feels like parts. Okay, so let me set it up as a parts equation. So the integral of U dV is equal to UV minus the integral of V du. Okay, so they want this one to be, maybe I should switch them. I'm going to make U f of x, because that's actually what I'm trying to find. I'm going to make U f of x, so let me write this integral. So 0 to 1 f of x g prime of x dx. Okay, so I think what I'm going to do is change that. Okay, and I think I'm going to make this one my u and this one my dv. So let's see how it works. So u, and then du would be f prime of x dx. And then if dv is the rest, right, this was u. So dv is the rest, g prime of x dx. V is the antiderivative, which is g of x. And then we do down minus the integral of across. Okay, so the answer would be f of x, g of x, minus the integral of across. So the integral of across would be f prime of x, g of x dx. And that looks like what they gave me, so that's kind of cool. Okay, so 0 and 1. Now, we don't do too many integration by parts with bounds, but we will have to evaluate with the 0 and the 1. So this would be f of 1, g of 1, minus f of 0, g of 0, and then minus, and this whole thing here, let me highlight so you can see. See where my highlighter is. I'm getting better at this. Okay, so my highlighter would be this whole thing right here is this. So that would be 5. Oops. I love that. That's so funny. Okay, so hold on. Let me get back to my pen. Okay, so here's my pen. Okay, let me erase that big highlighter. Okay, there we go. So minus 5. Okay, and then f of 1 according to the graph, or the table, f of 1 is equal to 4. G of 1 is equal to 3. F of 0 is equal to 2. And g of 0 is equal to negative 4. Minus 5. So 12 plus 8 minus 5 is 15. Answer E. And let's see, Mr. Calculus also got E. So good. Good. Okay. You take a look at that one. What made me think of it? I saw 2 functions being multiplied, one with a derivative. That makes me feel like v du, u dv. Once you know it's integration by parts, that would be much smoother, but trying to figure out its integration by parts definitely is not the easiest thing. Okay, so let's see, 23. Taylor series. Now this is interesting because this is actually a Maclaurin series. So in the new 2020 test that's only 45 minutes, it does say Taylor series are on the test, but it doesn't specifically say Maclaurin series are. So it would be possible for you to do this one by taking repeated derivatives. But you do know that this is a Maclaurin. So since you know that it's a Maclaurin, we can use our Maclaurin ideas instead of taking repeated derivatives. So let's write our sine formula. Okay, so sine is odd exponents. Okay, so they're odd exponents and they are alternating. It goes to 7 or 8, so I'm thinking let's do a couple more. X to the 9th over 9 factorial minus ... And then I would have you change it to a u by overwriting it, but I'm thinking it might be nicer just to rewrite it. So sine u is u minus u cubed over 3 factorial, you know, because that does look like a mess when we do that. Okay, minus u to the 7th over 7 factorial plus u to the 9th over 9 factorial. A minus ... Okay, now I want the sine of 2x. So I'm going to put the 2x where the u is. So 2x, okay, so 2x is where all the u's are. Okay, so this would be sine of 2x. That's a plain 2x. That's 2x over 3 factorial. That's plus 2x to the 5th over 5 factorial minus 2x to the 7th over 7 factorial plus 2x to the 9th over 9 factorial minus ... Okay, so that's my sine of 2x. And it looks like I'm going to need to simplify that if I look at all the rest of the problems. So let me simplify. Okay, so this would be sine 2x is 2x minus 8x to the 3rd over 3 factorial. The factorials are left, so let's not work those out. 32x to the 5th over 5 factorial minus 128x to the 7th over 7 factorial plus 2 to the 9th, x to the 9th over 9 factorial minus ... If you are doing a free response, you got to make sure that you do have the minus ... there. Okay, so minus ... Okay, so then it says x in the front. So what am I going to do with the x in the front? So I'm going to multiply by the x in the front. So the x in the front, I want to times, which means I want to times, let me erase this. So I want to times on the other side as well. I'm just moving my equal sign. Okay, so I'm going to multiply both sides by x. Now, when I multiply the right side by x, I'm going to have to multiply the whole thing. So then you have to think of your algebra rules. So what's my algebra rule if there's an x in the front? It would be distributing. Now, if I was just adding, I would add like terms. So if it was x plus sine 2x, I would only add it to the 2x, and I wouldn't add it to everything. 2x squared minus 8x to the 4th over 3 factorial plus 64x to the 6th over 5 factorial minus, that's probably enough terms. I wonder what I did wrong. I see my 2x squareds. Oh, I don't know why I multiplied 32 by 2. Okay. Okay, multiple choice saved me. Okay, so 32, I should only add the exponent. I don't know why the 2 all of a sudden changed. Okay, so 32, x to the 5th, x to the 6th. Okay, I like this one. So this one is the answer. So 128x to the 8th over 7 factorial plus ... There we go. So if it was free response, this is what I have. I have all my steps. So it's good to have all your steps regardless, whether it's free response or multiple choice. Okay, and let's see, Mr. Calculus's answers here ran out. He's in his next section, and he got the same answer as me. Good. Okay. Let's see, how many did we just do? I believe we started on the logarithm one, 19. So we did 19, 20, 21, 22, 23. Let me look at what the next one is. I'd like to talk a little more about logistic. So let me stop here. Let me go back to this one, and we're at what, 23? So 19 through 23. Okay, let me stop the video here, and then I'll make a new video.